In this chapter, we will cover the types of angle measurements, the definition of a radian, and then radians in a circle.
Degrees are okay for quadrangles, but the math will get us in tangles. To improve calculation, when we measure rotation, we will only use radian angles. One of the standard units of measure in the SI system is the radian, and the radian requires a little bit more explanation, so we're going to give it a little more treatment in this chapter.
There are two types of angle measurements. Static angles are measured in degrees. Rotating angles are measured in radians. When we're measuring static angles in degrees, that's familiar to us and is convenient for trigonometry. When we look at some of these diagrams that you'll see quite a few of wheels and lots of angles in them, we will use degrees to measure those. Measuring radians is less familiar to many people, but it's far superior for rotational calculations. So anytime we're doing something that involves rotation of wheels, we will use radians. So what is a radian? Here is a circle showing 0 degrees, 90 degrees, 180 degrees, and 270 degrees. This is what you would normally see in a geometry textbook. The problem is I want to be able to show an increase in the number of degrees starting from 0 as a wheel rotates clockwise. So in this video, you'll see 90 degrees at the bottom of the circle and 270 degrees at the top. The black line here depicts the length of radius r. Here we see an arc inscribed on the circumference, and the length of the arc is 1 radian, which is equal to the length of the radius. 1 radian is equal to 57.3 degrees. Going around my circle, I have 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. Now at 180 degrees, I have 3.14 radians. 3.14, of course, is pi, so that is pi radians. At 90 degrees, I have pi over 2 radians. At 270 degrees, I have 3 pi over 2 radians. Here at 0 degrees or 360 degrees, I have 6.28 radians, which is 2 pi radians. And one more time, I have 0 degrees or 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and over here, 2 pi radians. There's nothing unscientific about using degrees to measure angles, and of course a radian is one of our fundamental measuring units. But when we're talking about rotating angles, radians are much better because they greatly simplify the calculations.